Assalamualaikum warahmatullahi wabarakatuh. Let's begin with Umar Kitab Al-Fatihah. Okay, we continue our discussion. Actually, this is the last part of the acid-base equilibria. So, acid-base titration curve. Okay, this is you did this actually in experiment 5. Okay. In chapter 4, we use titration to quantify acid-base reduction. Okay, in this section, we focus on the acid-base titration curve. What I mean by acid-base titration curve here, it is a plot of pH versus volume of titrant added. Mean the titrant here is that substance or chemical within the burette, right? We discussed curve. We're going to discuss curve for strong acid, strong base. That means titration of strong acid and strong base, and then weak acid and strong base, and a weak base, strong acid. All right. Okay, polyprotic acid and strong base titration also we have actually, but for our syllabus is not covered this part. Running a titration is an exercise for the lab, but understanding the role of acid-base indicator and saying how salt solution and buffer are involved, apply key principle of acid-base equilibrium. Okay, of course, when we running a titration, you know it is neutralization reaction between acid and base, and then we look how the pH change as the titrant added. But also, important rule that you have to take note that indicator involved here. So the role of indicator, acid-base indicator, is important. All right, where we can see the change of colors indicates the endpoint. If not, without indicator, we cannot see the change. All right, we cannot identify the endpoint, which is to be close to equivalent point. Okay, the two terms here, two different terms, endpoint and equivalent point. So without acid-base indicator, we cannot indicate the points. Okay, and also within the reaction, how the salt solution, saying how the salt solution produce. All right, as you know, some salts neutral, some salt acidic, some salt are basic. All right, we discussed that before. And then also buffers involved in certain cases. In certain cases, in certain titration, there's a region where buffers system involved. Right. So this important, the three important things together with the neutralization reaction. Okay. Of course, monitoring pH with acid-base indicator. We have to choose a suitable indicator from the rack because we have many indicators actually. All right. This is example of indicator that we can use, but we cannot simply choose any indicator for any titration. We have to choose a good indicator because the pH range when the color change differs from each other. We go detail on this later, so I skip this part. How to choose a good indicator for our titration. All right. Cuma I want to highlight that mostly for our level we use either of the two, methyrate and phenolphthalein. This is widely used for our level of reaction. Okay, phenolphthalein quite common, right? I'm quite sure you did. When you did the lab, you did phenolphthalein. All right. Sometimes also we use methyrate. Okay, but the rest rare lah for our level. Okay, all right. So I skip this part. How to choose the acid-base indicator. Okay, I go to the first type of titration between strong electrolyte. Here, this is strong acid and strong base titration curve. Strong acid and strong base titration curve. Okay, all right. All right, we can see here figure 19.8 shows a typical curve for the titration of a strong acid with a strong base. Here, what is the strong acid? The strong acid is HCl, all right, 0.1 molar HCl, and then the strong base is 0.1 molar sodium hydroxide. The data used to construct it. Okay, of course, first you do titration, you record every mil you add the sodium hydroxide. Okay, this is you did first. You do first in the carry out the experiment in the beaker. What in? Okay, I want to ask you, what in the beaker? Now.
HCl, sir.
Huh? HCl. Okay, how do you know HCl is in the beaker?
Berdasarkan graf, sir.
Okay, from the graph. Okay, from what information that you see, you notice that HCl in the beaker, so the other side in the burette.
As exist.
As?
As exist.
As exist. As exist. Okay, alright. So volume of soda hydroxide added means the soda hydroxide in the
Burette.
In the burette, correct. So HCl in the beaker. So 40, that's why I mentioned titration of 40 ml of 0.1 molar HCl. So now in the beaker, solely at the beginning, HCl 40 ml 0.1 molar. Right. Then of course record the pH at initial at 0 means before sodium hydroxide is added. Okay. So pH here. Okay. Of course negative log 0.1 lah. Negative log 0.1 you get pH equal to 1. Kan? Betul tak? Okay.
Yes.
Alright. Negative pH equal to 1. Then slowly sodium hydroxide is added. Okay. First 10 ml. Okay, put 10 ml sodium hydroxide. Then record the pH 1.22. 20 ml sodium hydroxide added. Maknanya tambah lagi 10 ml lah. So, right, faham tak? 10 ml lah from here. 10 ml, now become 20 ml, right, total. So the pH is 1.48. Add another 10 ml. Now total volume for sodium hydroxide is added is 30 ml, so 1.85. Okay. So that is the experiment carried out. Actually, this you did in the lab. Ini yang kamu buat dulu kan. Record the pH. After few ml added of sodium ni, tak kisahlah acid or base, you add, then record the pH. Record the pH, right? Okay. Until you get after depend on the volume here. Kalau ke sini until 80 ml. Sampai 80 ml added, then record all the pH. Okay, you get this data, then plot the graph. Okay, plot the graph here, then you get this we call as titration curve. Faham? So maknanya data ni dulu. This data come first, then this plot come later. Okay, alright. Boleh faham Okay, alright. Then kita, kalau if you look at the titration curve, kalau kita nak go in detail making analysis on this titration curve, right? Kita tengok. Okay, at the beginning solely hydrochloric acid in the beaker, right? So what's present in the beaker? Okay, of course HCl dissolved in water. So what you have is hydronium ion concentration, hydronium ion and chloride ion lah. Right. Of course water as the medium too. We have that. Okay, you have hydronium ion and HCl. So this process hydrochloric acid dissociate completely. So whatever molar you put, right, for the case you put 0.1 molar hydronium ion, then you have 0.1 molar hydrochloric acid. That means you have 0.1 molar hydronium ion. Okay, betul lah? Alright, at first, at the initial. Then, okay, kita ambil region before this region. Okay, take 1 point. Okay, take here at 20 ml, for example, right? Okay, what is total volume right now? Kalau tadi 40, now you add 20 ml, now we come for 60 ml, right? Okay, what present in the solution? Of course, the present in the solution now, hydronium ion, because it's not equivalent point. This is before equivalent point, maknanya you still have a certain amount of hydronium ion present. Since here sodium hydroxide is a limiting reactant, so sodium hydroxide is finished lah, habis. So what present? Remaining hydronium ion, and then you have sodium ion, of course lah, because sodium hydroxide react with the HCl producing sodium chloride. So you have sodium ion and chloride ion. Okay. Alright, then at equivalent point, kami at equivalent point, because here the ratio is 1:1, simple, because sodium hydroxide react with hydrochloric acid producing H2O and sodium chloride. The ratio of acid and base here is 1:1. Boleh faham kalau if you write the equation, and okay, hydrochloric acid plus plus sodium hydroxide. Produce sodium chloride and water. Okay, alright. So this is valid equation. So from the stoichiometry here, we know 1 to 1. That means equivalent point here, of course, 40 ml sodium hydroxide added. Okay, so 40 ml and 40 ml of 0.1 molar sodium hydroxide added into 40 ml of 0.1 molar hydrochloric acid. So that is equivalent point. So since ratio is 1 to 1, the stoichiometry. So this is complete neutralization. No, maknanya at 40 ml added now sodium hydroxide, no more remaining, no more, tak ada lagi the remaining hydrochloric acid, all finished. It completely react with the sodium hydroxide. Okay, total volume is 40 ml. Okay, and no remaining, no sodium hydroxide. Sodium hydroxide pun complete reaction. No more, no excess sodium hydroxide. So you have what present in the solution? Complete neutralization, produce sodium chloride and water. So you have Na and Cl. And this is neutral. Nampak neutral? Kenapa neutral? Because sodium ion and chloride ion, this is negligible strength to react with water. Tak ada apa? It is a negligible strength. Therefore, they create neutral salt solution. Ingat tak? For case of neutral salt solution, the ion is from strong acid and strong base. Alright. So sodium ion is cation of strong base. Cl minus is anion of strong acid. So of course here it create neutral salt solution. Okay. Before that of course acidic. Before that is acidic. Before equivalent point is acidic. Alright, because you still have remaining hydronium ion present. Okay. Alright. Then okay. Then beyond equivalent point. Lepas, after equivalent point. Okay, after equivalent point. Kita tengok sini ya. After equivalent point, of course hydrochloric acid habislah. So whatever sodium hydroxide added after that, right? So the sodium hydroxide become excess. Sodium hydroxide become excess. Okay, you can see excess now. So in this case, apa ni? What present in the solution? Of course, what present is excess hydroxide, and then salts present. Okay, salts, nothing happen on it, so salt is neutral, but we have excess hydroxide. Alright, hydroxide ion. Total volume now, pada case ni, kalau at this point, they take at 60 ml. So hydroxide is added. So maknanya dah extra 20 ml. From 40 just now, extra 20 ml. So now you have extra sodium hydroxide. Therefore, the solution now become basic lah. Beyond the equivalent point, after the equivalent point, it become basic. Alright. Alright. We go in. Okay, I just go this here. Feature of the curve, there are three distinct regions of the titration curve which correspond to the three major change in slope. Okay, the pH starts out slow, reflecting the high hydronium ion concentration of the strong acid, and increases slowly as acid is gradually neutralized by the added base. This is referred to this region. Right, gradually increase. Right, as acid, some of the acid neutralized by the added base. Okay, slowly increases, the pH increase slowly. Okay, second, the pH rises 6 to 8 unit very rapidly. In this case, in this region, all right, you see this region, the volume added is very small, sikit je, tapi what you see the pH change, very small. It's around less than 5 drops. Dalam kasus ni, dalam less than 5 drops, 5 titik, kurang daripada 5 titik. But the pH increase rapidly, drastically. 5 titik ni tak sampai 0.2 ml, tapi the pH increase slightly. Okay. This steep increase begin when the amount of hydroxide ion added nearly equal to the amount of mole of hydrogen ion originally present in the acid. So the hydroxide ion added now nearly equal, the amount here of the hydroxide ion nearly equal to the amount of hydrogen ion. So 1 or 2 more drops of base neutralize the remaining tiny excess of the acid and introduce a tiny excess of base. So mana tambah satu drop, dua drop tu dah make the solution become basic. Become basic. Tiny excess make the solution become basic. Okay. And then beyond after that, the pH increase slowly beyond the steep rise as more base is added. Maknanya, here lah, at this region, increase gradually as more base added into the conical flask. Sorry, I mentioned beaker before this. No, flask, conical flask. Sorry. Alright. Okay, until here, is there any question you want to ask? Ada soalan ke nak tanya? Tak ada?
No, sir.
No, sir. No question. Alright. Okay, I mentioned to you there are two terms I mentioned before that mention about points, equivalent point and the end point. What different? Let's distinguish between the 2 points. What is equivalent point and what is end point? Okay. Equivalent point where this is the equivalent point. Dalam case this titration curve, 40 ml of sodium hydroxide added, this is the point we call as equivalent point. End point, apa pula end point ni? End point ni when the color change. When the color of the indicator change. That is end point. Change permanently. It change permanently. If we use methyrate, so it change from red to orange, like that. Kalau letak excess lagi dia jadi kuning, it become yellow. Actually that is basic already, more excess already. So equivalent end point here is around red colors. For if we use phenolphthalein, kita tak boleh guna dua-dua tau. We choose one of them. If we use phenolphthalein, then the color is pale pink. That is the end point, and this change permanently. Kalau you ingat kan, when you do titration tu, when it is close to end point, it's typical. When you drop, you see the color pink, but then suddenly as we swirl the conical flask, then it disappear. Maknanya it's not changed permanently yet, maknanya not reach yet the end point. Until a point, you reach the end point, then the pale pink permanently there. Lepas tu kalau you add 1 drop more, then it become intense pink lah, color yang pink yang terang lah, yang intense. So maknanya itu actually dah access already. Alright. So that is end point. End point and equivalent point. Itu beza dia. Equivalent point equal this point, maknanya equal 40 ml lah, dalam kes ni 40 ml of sodium hydroxide is added to 40 ml of 0.1 HCl. Okay. So a good indicator, okay, ni saya tambah sikit, a good indicator end point close to the equivalent point. Macam kes ni lah, methyrate and phenolphthalein, this is a very good indicator. Both of them is a good indicator. Why? Because it's very close to equivalent point. 1 or 2 drops, you reach the end point. Okay, 1 to 2 drops nearly to equivalent point, then you reach the color change. Alright, end point. So a good indicator, end point and equivalent point is very close. Okay, kita lihat. Okay, the equivalent point occurs when the number of mole of added hydroxide equal to the number mole of hydrogen ion originally present. Equal moles. So bila equal mole, complete neutralization. There's no more excess sodium hydroxide, no more hydrogen ion present. What present in the conical flask now is totally salts and water. Okay, the solution consists of the anion of the strong acid and the cation of the strong base, the salts. recall from the chapter 18 that this ion do not react with water, so the solution is neutral, pH is 7. This is neutral salt solution. Okay, this is neutral salt solution because this ion do not react with water. You got it? Boleh faham? Alhamdulillah. Okay, then the endpoint. Okay, what about the endpoint? The endpoint occurs when the indicator which we added before the titration. Sebelum titration kita tambah dulu indicator kan. Jangan tengah-tengah titration tu kita tambah indicator. That is wrong. So we added before the titration and change color. We choose an indicator with a color change close to the pH of the equivalent point. Kita pilih yang So the figure 19.6 includes two indicator yang figure atas tadi. And two indicator figure. Alright. Either one lah actually. When you carry out experiment, you boleh buat two different titration, one with phenolphthalein, one with methyl. The same titration. Okay. And then so figure includes two indicators suitable for strong base titration, strong acid, strong base titration. Methyl rate change from red at pH 4.2 to yellow at pH 6.3. Okay, it is narrow here. It changed from pH 4.2 to 6.3, and phenolphthalein changed from colorless at pH 8.3 to pink at pH 10. Neither change occur at the equivalent point. Dalam kes ni, the two indicator neither change at equivalent point, but both occur on the vertical portion of the curve. Tapi maksudnya both occurs at the vertical point, vertical line. Mana change occurs at vertical line. Maknanya between less than 5 drop the change occurs colors. Both. So mean is very nearly to the equivalent point 40 ml. Dekat. Nampak? Kalau indicator tu, kalau kat sini dia tukar dah color, which is in term of volume very far lah. You look at the volume, this is very far, around 35. Kalau kat sini dia dah change the color, so mana is not good because the volume is 35, it already changed. Kalau ataupun indicator change color at this point, so this is not good. Maknanya it's far from 40 ml, jauh daripada 40 ml. A good indicator, it is very close. As I said just now, it's very close. Maknanya this is methyl and phenolphthalein both change the color within this vertical line. It shows that the volume added is very small than the color change, so very close to pH 7. Okay. Therefore, when methyl rates turn yellow or phenolphthalein turn pale pink, we are within a drop or two of the equivalent point. Mana a drop or two drops of the equivalent point. In practice, then the visible endpoint signal the invisible equivalent point. So in practice, because we cannot get the right volume of at equivalent point when do the titration, tapi with good indicator, maknanya the endpoint is very near to the equivalent point, one drop or two drop. One drop ni around 0.05 ml, lebih kurang macam tu lah. So which mean the volume of the endpoint signals that the volume of the endpoint we can use in the calculation. Kita boleh buat calculation untuk calculate. For example, biasanya what is the purpose of titration ni, we can kalau different kalau ni to calculate concentration lah. Tapi dalam case ni dia dah mention the concentration both. Tapi yang asalnya titration ni, you know the concentration of one component, you don't know, you can use that by titration to determine the concentration of other component. Mana kalau case ni contohnya you tak tahu concentration of acid, but you know concentration of base, so you can use titration to determine the concentration of acid. So we need the volume. Kita perlukan the volume, right? So volume here is endpoint, not equivalent point. But since it is a good indicator, so endpoint to very close to equivalent point, one drops only change, one or two drops different. So we can use that volume to determine in calculation to determine the concentration. Kita boleh guna. Kalau you guna bad indicator jauh daripada endpoint, endpoint far from the equivalent point, different dia macam 5 ml, right? Difference. Then, of course, if you take the endpoint values to calculate, then you get the concentration. You dapat far lah the concentration from the right value, jauh daripada the right value. Understand? Boleh
Okay, calculating the pH during this titration. Okay, by knowing the chemical species present during the titration, we can calculate the pH at various points along the way. First point is at initial. At initial means before added with strong base. Okay, initial solution of strong acid here. In color case ni figure 19.8 just now. Alright, figure 19.8, 40 ml of 0.1 molar hydrochloric acid. So how to calculate the pH? Okay, straightly simple. It's just you know the concentration of the hydrochloric acid, right? 0.1 molar. So 0.1 molar hydrochloric acid produce 0.1 molar, right? Hydronium ion. Because a strong acid is completely dissociated, right? Therefore, the initial pH, negative log, the hydronium ion concentration, this is 0.1 molar, so pH equal to 1. Simple. Simple and straight. Okay, what about before equivalent point? Now point number 2, before the equivalent point. Okay, as we start adding base, some acid is neutralized and the volume of solution increases. Okay, two things happen as we start adding base. Some acid is neutralized, right? And the volume of the solution increases. Okay. To find the pH at various points up to the equivalent point, we find the initial amount of hydronium ion and subtract the amount reacted, which is equal to the amount of hydroxide added, to find the amount of the hydronium remaining. Then use the total volume to calculate the hydronium ion and convert to pH. For example, kita ambil contoh after adding 20 ml of 0.1 molar sodium hydroxide. Okay, after adding 0.1 molar sodium hydroxide. Okay, at this point, how to calculate the pH? Okay, how to calculate the pH after added 20 ml? Okay, then we find the amount of hydronium ion remaining. Okay, initial amount of hydronium remaining, volume time the concentration. All right, you get 0.04 mole. That is the initial amount of hydronium ion. Then you add hydroxide ion, correct? Okay, of course here the hydroxide ion 20 ml, so 0.02 liter times 0.1 molar, you get 0.002. So this is limiting reactant here. So this is excess reactant. So what remaining amount of hydronium ion present now minus of that 2, you get 0.02 mole hydronium ion concentration. Okay, you get the mole of hydronium ion. To calculate the pH, you need concentration, correct? So how to calculate the concentration now? Okay, you need to divide by this. We need to divide by the total volume, because now one solution dilutes the ion in other. Okay, means amount of mole of hydronium ion remaining 0.02. So now what is the total volume? Okay, originally the volume of acid is 0.04 liter, 40 ml, right? 0.04 liter. So volume of added base is 20 ml. So this is 0.002 liter. So divide by that, the total of this. So mole of hydronium ion divided by total volume of the solution. Now you get 0.0333 molar. So that is the concentration of hydronium ion. So to get the pH, just negative log of that, you get 1.48. All right. Continue. At the equivalent points. At the equivalent point mean 40 ml of 0.1 molar sodium hydroxide has been added to the 40 ml of 0.1 molar hydrochloric acid. Okay. So what is the mole present in for the 40 ml of 0.1 molar? It is 0.004 mole. Whereas the hydronium ion also is 0.04 mole. Therefore, the equilibrium point is reached. So now what is present in the solution is sodium ion and chloride ion. And both of them, neither of them react with water. Dua-dua ni tak negligible strength to react with water. So because of that, now it depends on the water itself. Water undergo auto ionization, producing hydronium ion concentration 1.0 times 10 negative 7. Therefore, negative log of this, you get pH equal to 7. Okay, I hope this is clear. Okay, after equivalent point mean from the equivalent point, the pH of calculation is based on the amount of excess hydroxide ion present. For example, kita ambil contoh after adding 50 ml of sodium hydroxide to the original amount of hydrochloric acid. Now total amount of hydroxide added is 0.05 liter times 0.1. To get that, to get the mole, you get 0.005 mole hydroxide ion. For the hydronium ion, yes, you know 40 ml, right, of the 0.1 molar, that is 0.04 mole. So amount of excess hydroxide is 0.001 mole hydroxide ion. This is the excess hydroxide ion present in the solution. So to calculate the hydroxide ion concentration, you get that, because, okay, we need the pH, right, at the end. So of course we need to calculate the concentration of the hydroxide ion, then later we calculate the pOH. So to calculate that, excess here 0.001 divided by total volume is now 40 plus 50 ml, right? So 0.09 liter. So you get the concentration of hydroxide ion is 0.01111 molar. Okay, so from here, negative log of this, you get pOH equal to 1.95. So how to get the pH? Simple, pH equal to pKW minus pOH. 14 minus 1.95, you get 12.05. Right, so that is how to calculate the pH at 4 points. At initial, before equivalent point, at equivalent point, and after equivalent point.